All right, so P2 is a lot of exponents, radicals. It's going to get into a lot of other stuff too, but we start with just that first part. We start with integer exponents. So an integer is a number, right, that could be positive or it could be negative. It's a whole number though. When it has an exponent, that's a whole number like these are. That means that you're going to multiply whatever the base is by itself that many times. So a repeated multiplication can be written in exponential form. This is your multiplication form and this is your exponential form. So if I had 5 A's, it'd be a to the 5th. If I had 3 negative 4's, it'd be negative 4 to the 3rd. And if I had 2x 4 times, it'd be 2x to the 4th. Notice this negative is inside the parentheses with the 4, and so it stays inside the parentheses with the 4 on the right-hand side. You guys can all see my screen, right? Thumbs up if we can see the screen. Yes, okay, perfect. Exponential notation, okay, has different parts. So if A is a real number, which just means it's not imaginary, which we won't talk about for a while, any real number, and N, which is going to be the exponent, is a positive integer, then we say that this is the base. So here the big number is the base. What it's being raised to is the exponent, so it has parts to it. A would be the base and N would be the exponent, and we would do it N number of times. So you're going to multiply it times itself N number of times. So you can either read this as A to the nth power or A to the power of N. It's the same thing. So if it was 2 to the 3rd, it'd be 2 to the 3rd power or 2 to the power of 3. Same thing, okay? You'll hear it a couple of different ways. All right, multiplying exponential expressions. If I am multiplying two bases that have an exponent, then I add. So you never, when you're dealing with exponents, you never actually do what your function is. If it's multiplying, you add. So if I multiply a times a to the n and a to the m, then I add those two exponents. In order for this to be possible, they have to be the same bases. If they are not the same bases, then I cannot combine them. They would stay separate. So if I had x to the 3rd times x to the 4th, the bases are the same, they're both x. I would add those two exponents to get to x to the 7th. If you actually, if you forget or you panic or you aren't trusting yourself, then think about it. This would be x times x times x times another 4. 1, 2, 3, 4. And then if you counted them, 1, 2, 3, 4, 5, 6, 7, there's my x to the 7th, okay? So you can always check your work that way. Questions so far? So when we multiply, we add. All right, let's do some examples. So if I have b to the 7th times b to the 4th, what is the answer there?
B to the 12th.
B, so close.
It's 11th.
B to the 11th, good. Okay, add the 7 and the 4, and I get b to the 11th. All right, there's your basic base with exponent. Now b says 3x squared times 4x to the 3rd. So you can group these. I'm going to group my coefficients. That's what's called the number on the front. And I would do 3 times 4, and I get 12 there. And then x to the 2nd times x to the 3 would give me what? X to the 5th. Good. We're going to add the exponents there, and I'd get 12x to the 5th. The number always goes on the front, variable next. If there's more than one variable, we usually put them in order of, what is with this hair today? Sorry, I have this little piece. It's driving me crazy. It would probably always go in alphabetical order. Now looking at C. C says negative 3x to the 2nd and 4x to the 4th. So I'm going to multiply the negative 3 times the 4, get the negative 12. And then x to the 2nd times x to the 4th, which gives me? X to the 6th. Good. Then I go to D, and D says negative 3ab squared times 5ab to the 4th. If you want to separate these out by letters, feel free. Like if it's confusing to work it out. One of the great things about like a notability, if you're using it, is you can kind of like highlight. So I'm going to highlight the two coefficients. I know I'm going to multiply those together. I'm going to highlight the A's. I know I'm going to multiply those together. And I'm going to highlight the B's in a different color. And I know I'm going to multiply those together. So I get negative 3 times 5, which is my negative 15. A to the third times A. What's the exponent on just A?
1.
There's a 1 there, so it's not 0. So I add those, A to the fourth, and then B to the second times B to the fourth, and I'd get
B6.
B to the sixth. Good. Everybody still good? Yeah?
Yeah.
Okay. All right, go to E. So I have an M to the second and an M to the first. That's going to be M to the third. I have an N to the first and an N to the fourth. That's going to be N to the fifth. And last one on this screen, I've got my coefficients 3 and 4, which would give me 12. I've got my variable y to the third and y to the fourth, which is y to the seventh. And I've got z to the first and z to the second, which is z to the third. We still good?
Yes.
Awesome. All right, I'm going to give you a couple minutes. You try these. Try example 2. They're just obviously getting a little bit more complicated because sometimes there's 3 terms there, but all the same rules apply. So if you need to highlight to separate them out, feel free to do that, okay? All right, so for A, we've got a -1 here, so it's not really like, there's not a 1 obviously, but that means there is a negative number there. You can keep it with the x, but I would be careful, kind of separate it out because that's something that's going to get multiplied by the 3, so -1 times 3 is -3 times a -2 means -3 times -2 is a +6. Then I've got all my x's, so I've got x to the second, I've got x to the first, and I've got x to the third. Add up all of those exponents and I get x to the sixth. Then I've got my y's, y to the third, y to the second, and y technically to the first. Third, second, first. Add those up again, and it's also an exponent that's 6. So 6x to the 6th times y to the 6th. Raise your hand if you got it right. Okay, good. All right, B says 5b to the fourth, -3a to the second, b, and -a to the third. So if I did my coefficients first, I have a +5 times a -3, that's -15, times a -1, that means this is a +15. Then I go to A, because in alphabetical order that would be next. A is not on the first one, but I do have an A to the second and an A to the third, which means this is A to the fifth. And then B to the fourth, B to the first, which is B to the fifth. Again, raise your hand if you got it right. Any questions before we move on? Fantastic. Good job, guys. I'm going to remind you that, remember in class, like I can see the panic on your face if you were sitting in front of me and you didn't understand, but on Zoom I don't see that, so please make sure you speak up if you have a question. I guarantee if you're confused on something, somebody else in here is too, so don't feel embarrassed, okay? Please ask. And if you want to chat the question and you don't want me to say your name, that's fine too. Feel free to chat your question and be like, don't embarrass me, Miss Chris Weiser, but give me your question, okay? All right, example 3. Now look at where these exponents are. Location of exponents are obviously going to impact the positive and negatives here. So this is a -x to the second, right? That's a -1 times x to the second. This is -x squared. Anything that has the exponent on the outside you want to complete first. So I actually have to square -2, or negative x, sorry, which means negative x times negative x, and that becomes a positive x squared. So if it's negative inside the parentheses, even number outside the parentheses, the negative goes away. If it's a negative number inside the parentheses, but an odd exponent, negative's going to stay, which we'll see in the next example. So then this becomes negative x squared, oh, the squared is in there, times a positive x squared. The coefficients are -1 and +1, which means this is negative. X squared times x squared is x to the 4th. So be careful and make sure you take care of any exponents on the outside before you multiply. Think about PEMDAS, right? My exponents come before my multiplication. So take care of your exponents first. So now look at B. B is negative x to the 3rd. This is already done, so this is going to get carried down. But this one is negative x to the 3rd. That means negative x times negative x times negative x. Odd number of negatives means that's going to stay a negative. So even exponent and the negative goes away, odd exponent and the negative stays. Now my coefficients are -1 times -1, which means it becomes a +1. X to the 3rd times x to the 3rd is x to the 6th. And that's just x to the 6th. Be careful with your exponents. Don't let them on the outside with the negatives. They get tricky. Questions on that one? All right, example 4, simplify the expression. Now we've got multiplication happening with addition or subtraction. So again, remember PEMDAS, or please excuse my dear Aunt Sally, okay? Your multiplication comes before your addition. So we're gonna take care of the multiplication first, then we're gonna combine like terms. So if I look at that first term here, the first multiplication is 5x squared times 2x to the 3rd. I do 5 times 2, which is 10. X squared times x to the 3rd is x to the 5th. Plus, take care of the second one. 3 times 4 is 12. X to the 1st times x to the 4th is x to the 5th. Now, hopefully we remember the rules on combining like terms, right? But they are that if your base is exactly the same, which in this case I have an x to the 5th and an x to the 5th, those are the same. Now I can combine these into one term. 10 plus 12 is 22, and the base and the exponent stay the same, the variable and the exponent. If that was like an x to the 4th and x to the 3rd, I cannot combine them. I would keep them separate. So you may see something like that in the homework. That's okay. You keep them separate. All right, next up is B. We start with 3 times 5, which is 15. A to the 5th times a to the 3rd, which is a to the 8th. Minus, this time, I do 6 times 1, 6. A to the 2nd times a to the 6th is a to the 8th. Again, these are like terms, so I do 15 minus 6, and I get 9. A to the 8th. We still good?
Yeah.
If I go to advance the next one and you're still copying down, please say, I'm still copying down. Because again, in the classroom, I would see you still writing. But right now, it's hard to tell. All right, now we've got raising a power to a power. This, again, we don't actually raise the power to a power, we would multiply. So when we multiply, we add. When we raise to a power, we multiply the powers. So if I had something like a to the m raised to the power of n, I would multiply the m and the n, and that's my new exponent. So the example there says x to the 4th raised to the 5th. I would multiply 4 and 5 out, and that would be x to the 20th. If you have a product, which means more than one term being raised to a power, that power gets distributed to each of the terms inside. So if I had 2x to the 4th raised to the 5th, this becomes 2 to the 5th x to the 20th. So just keep that in mind. And then 2 times 2 times 2 times 2 times 2, that's 32. Oh, that's sloppy. 32x to the 20th. So multiplying we add, raising to a power we multiply. Again, you never do the actual thing that you think you're supposed to do here. And if you were unsure, I wouldn't want to do it x to the 4th to the 5th, but if I had like x squared or a squared to the 3rd, that means I have 3 a squareds. So a squared times a squared times a squared, which is a times a times a times a times a times a. You count those up, and there's 6 a's. But obviously, I wouldn't recommend having to write out x to the 20th like that. So just make sure you remember your rules. All right, Audrey, just do the best you can. I know that Wi-Fi is still rough right now, okay? Remember everything I'm doing. I'll slow down a little bit, but remember that everything I'm doing will be on both the Zoom video and the YouTube video. So if you're glitchy or something happens with Wi-Fi, remember it's always there. You can leave and come back if you want to try that, though, of course.
I'll just look it up on YouTube after.
Well, I mean, you want to try first? I'll pause and wait. All right, let's work through these examples. So A says 2x to the 3rd. Remember that this is a product being raised to an exponent, which means that exponent's going to go to both parts of my product, which becomes 2 to the 3rd, x to the 3rd. You can also look at that as 2x times 2x times 2x. Multiply out your coefficients, multiply out your exponents. How you do that is completely up to you. Okay, they are both the same thing. 2 times 2 times 2 is 8. So this is 8x to the 3rd. For the next one, I'd get 2 squared and then x to the 5th raised to the 2nd. So what's 2 squared? Wait for it. Wait for it. It's 4. Good. And x to the 5th raised to the 2nd is? X to the 10th. Good. Remember I told you I'm going to wait until it's like uncomfortably awkward until somebody answers me. All right. Then C. Now I've got that negative, right? So when I distribute this exponent, it's going to a negative 2. It's negative 2 squared. Then x to the 5th raised to the 2nd, which becomes a positive 4x to the 10th. Am I totally frozen? I am. You guys got to tell me, right? You don't see this screen. All right, D says negative 2x to the 4th raised to the 3rd. So this is a negative 2 raised to the 3rd. And then x to the 4th raised to the 3rd. That's negative 2 times negative 2 times negative 2. It's an odd number of negatives, right? So my answer is going to be a negative 8. And then x to the 4th raised to the 3rd would be x to the 12th. E now has 3 parts to it. The negative 3, that's going to get raised to the 3rd. The x to the 2nd, that's going to get raised to the 3rd. And the y to the 5th, that's going to get raised to the 3rd. So negative 3 times negative 3 times negative 3 is negative 27. X to the 2nd raised to the 3rd, x to the 6th. Y to the 5th raised to the 3rd, y to the 15th. questions on that one? Sorry, Madison, my volume's all the way down. Say that again.
I'm still copying.
Okay, perfect. All right, so let's go over them. For A, you want to multiply first the coefficients, right? So 3 times 2, and I get 6. A to the second times A to the third, which becomes what?
A to the 5th.
Good, A to the 5th, and, oh, sorry, wait. No, we did that all wrong. I did that on purpose, right? What do we have to do first?
Distribute the exponents.
Good, the individual exponents. So the first thing I have to do is take care of this guy. This is going to go to each of these, and that becomes 3 to the third, A to the second raised to the third, or A to the sixth, B to the first raised to the third, which is B to the third. And I get 27, A to the sixth, B to the third, okay? Now that's the simplified first one. Second one, again, I take care of the exponents first. 2 to the second, which becomes 4. A to the third raised to the second, which becomes A to the sixth. And B to the first raised to the second, which becomes B to the second. Now I multiply out my coefficients. So 27 times 4, 108. It's been a long time since we multiplied. A to the 6th times A to the 6th, which means A to the 12th. And B to the 3rd times B to the 2nd, which means B to the 5th. So be really careful here, because common mistake, 1 is do what I did first, right? 2 is work out the individual ones, but then think this is a plus in between. And then you try to combine the like terms, right? Which is not the same thing. 1, you wouldn't be able to combine those like terms because they're not like terms. But 2, you want to make sure that you know which those operations, make sure you follow the correct ones, which would have been multiply, not add. All right, now we go to the second one. So A to the second raised to the fourth, or sorry, 2 to the second raised to the fourth is 2 to the fourth. Then X to the second raised to the fourth is X to the eighth. Y to the third raised to the fourth is Y to the 12th. 2 times 2 is 4, times 2 is 8, times 2 is 16. X to the 8th, Y to the 12th. Times -1 raised to the second power, which means this is going to be positive. X to the, so that becomes positive. X to the second. Y to the second raised to the second is Y to the 4th. Again, if that was an addition in between, we cannot combine like terms because they're not like. This is multiplication, so we're going to multiply that out. 16 times 1, much easier multiplication. That's 16. X to the 8th and X to the 2nd would be X to the 10th. Y to the 12th and Y to the 4th would be Y to the 16th. All right, notice C is different because it has the plus symbol in between, right? So please make sure you read these carefully. I'm going to do first the exponents on each individual parentheses. So the 3 comes into here, 2 to the 3rd, which is 8, X to the 3rd. That is times, bring this in, X to the 2nd, Y to the 2nd. Plus, make sure you're carefully writing the plus. You don't change that to multiplication. The next one is already, there's no exponents on the outside, so I don't need to distribute. It would just be 4x squared, y squared, negative x to the 3rd. Now I'm going to multiply out these individual, multiply out these individual groups. So from the first one, I would get 8 times 1, there's really a 1 there, which is 8. X to the 3rd times X to the 2nd, which is X to the 5th, Y to the 2nd. Carry down my plus. 4 times a -1 means this is going to be a -4. x to the second times x to the third is x to the fifth, y to the second. Good so far? Now a plus negative is obviously meaning this is now subtraction, right? So if these are the same terms, which they are, they both have an x to the fifth and a y to the second. No additional, right? Those match exactly. I am going to do 8 minus 4, and I get 4 x to the fifth, y to the second. There was a lot of steps in there, so be really careful. That's when people make silly mistakes, and that stinks, right? You don't want to get a question wrong because you forgot the negative or you multiplied in your head wrong. So just be really, really careful on stuff like that. Questions on any of those three? Awesome. All right, last one. Now what we have not done is dealt with negative, right? Dealt with fractions or exponents that are 0. So that's what these are, right? When you're dividing and you've got the same variable in the top and the bottom, you actually subtract the exponents. In this case, we're going to distribute that exponent. Now that exponent is going to each term in the fraction because it's in parentheses and it's outside. If it was just 3x to the third over 2y, now that 3 just goes to the 3 and the x, right? The exponent just goes to the 3 and the x. But what we have is an exponent on the outside, which means it's going to every single term. So I end up with 3 to the third, x to the third, over 2 to the third, y to the third. If there were exponents already on the variables, when I raise them to the exponent, now we're raising a power to a power. Even though it's in a fraction, it's still the same rules. So I get 27 x to the third over 8 y to the third. If I can reduce, I do. But 8 and 27 do not have any common factors, which means my answer stays that way. If I had the same variable in the top and the bottom, then I can simplify those. But an x in the top and a y in the bottom means I can't cross anything out, right? All right, so what's the difference between B and C? Who can tell me the difference between B and C? B and D.
That the exponent is outside the parentheses in C.
Good. So the B...
You have to distribute it.
Good. The D exponent's outside the parentheses, which impacts the negative. Whereas B, and this is something that people make the mistake of all the time, so be careful. This is actually negative 4 times 4. So the negative is applied last, which means this is a negative 16. Whereas this, D, is a negative 4 times a negative 4. That negative is attached to the 4, and that becomes a positive 16. And your calculator, this is where you got to be smarter than your calculator, because if you plug that in, it's going to be wrong. So be careful. If you put it in parentheses, it will know to get rid of it. But if you just did negative 4 squared, it will make it positive 16. So be really careful. If it's an odd exponent, like this one, it doesn't matter, right? Because if there's an odd number of negatives, it stays negative. If I kept that negative on the outside, did 4 times 4 times 4, I'm still going to get negative 64. If I did negative 4 times negative 4 times negative 4, it's still negative 64. So that rule will only give you the wrong answer if it's an even exponent. And 4 to the 0, or any base to the 0, is 1. And there's absolutely no way to do that with arithmetic. You have to just know that. Your calculator will know that if you put it in. But there's no way to multiply 4 times itself 0 amount of times to get that answer. So be careful. Anything to the 0 power is not 0. It is 1. Questions on anything we covered today? Okay, P2 homework, P2 part 1. So I think we called it P2A homework is on Canvas. It is due by 8 a.m. tomorrow. Have a great day.